Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Briana Wyatt and Dallas Williams. Golf courses are well known for their beautiful greens, but overusing fertilizer and water to keep them looking pristine can lead to inefficient, expensive, and environmentally damaging waste. Precision agriculture can help, but only if we can find the right methods to put it into use. In this episode, Briana and Dallas join me to discuss their research on how electrical conductivity can be used to help determine golf course needs. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Briana Wyatt and Dallas Williams with us today. Briana got her bachelor's in environmental science at Oklahoma State University, then continued at OSU for her master's and PhD in soil science. She began working at Texas A&M in 2020 and now works to provide useful information and tools that will allow fellow researchers, land and water managers, and the public to better steward the increasingly threatened soil and water resources of our planet. Dallas got her bachelor's and master's in soil science from the University of Nebraska-Lincoln. She's currently a PhD student in soil physics and hydrology at Texas A&M University. Over the years, she has become very passionate about urban soil hydrology, community science, and strengthening community-university relations. Hi, Briana and Dallas. How are you both doing today?
Hi, we're doing good.
Yeah, we're doing pretty well.
Awesome. Well, I am so excited to talk with you today. We're talking about one of my favorite topics, which is golf course management. Always happy when that comes up. Super fun. And specifically, we're going to be talking about precision turfgrass management in this setting. So if you can just start us off by explaining kind of what precision management means in this setting, why it's important. Let's start there.
Yeah, so precision turfgrass management is just an overall term for applying both water in terms of irrigation water and fertilizers to specific areas in golf courses as opposed to applying water and fertilizers equally over the entire area of a golf course. And so this allows golf course managers to target areas that maybe need more or less water or more or less fertilizer. And it really has multiple benefits. The first benefit is that it reduces the amount of water and fertilizer that they need to apply, but also it saves water and it reduces the amount of potential pollution that might happen from those fertilizers.
So, a good analogy for precision turfgrass management is medical care in humans. So, think of the golf course superintendent as a doctor, and think of a fairway as being a doctor's patient. So, each patient is unique. Each patient has different lifestyle, different underlying conditions, all different contributing factors that make up their overall health. So, what may be good for one person may not be good for another. Well, golf course fairways are also unique, as they could be comprised of different areas of the landscape, so they can vary in elevation, types of soil, sun exposure, things like this. So all of these elements contribute to the overall turfgrass health of a fairway. So similarly, what may be good for the northeast corner of the fairway may not be good for the southwest corner. Now, a good doctor would not make the same uniform recommendations for all of their patients, as they realize the importance of each person's variability. And a doctor would take those things into consideration when treating a patient so they aren't over-medicating or under-medicating anyone. And a doctor that takes the time to treat each patient as an individual usually gives the most effective treatments. Well, when golf course superintendents don't consider the spatial variability within fairways and apply uniform irrigation and fertilizer applications, some areas may be getting the right amount of inputs, but other spots may be getting too much or too little, which can result in poor turfgrass quality or wasting water or fertilizer. So, just like the best doctors consider the needs of each patient individually, golf course managers should consider fairway variability when meeting turfgrass needs.
So, as part of this, there are a few terms that I think would be helpful for our listeners to know. So, I'm going to just rattle all four of them off, and then you two can run with it from there. So, the first one is going to be management zones, both what they are and how you create them. Electrical conductivity and electromagnetic induction sensors. That's a 2 for 1. I actually have five. Just kidding. Fairways, I'm sure a lot of golfers know about that, but I was not 100% confident, so I threw it in here. And then NDVI.
Management zones are based on variations within the fairway, whether it's in elevation, the amount of sunlight that it receives during the day. So, depending on these natural variabilities within the fairway, different spots might require more or less fertilizer or irrigation compared to others. So areas that receive similar inputs are grouped together into a similar management zone. And so basically you go through your fairway and find all of the similar areas, create your management zones, and then apply fertilizer and water based on those specific requirements. Fairways fairways are the part of the golf course that lies in between the tee box where you tee off and in between the putting green. So it's usually a long stretch of grass that gets a lot of fertilizer and water to keep it looking really nice.
Sure.
So the electrical conductivity is the ability of a soil to conduct an electrical current. And this is important because it's highly correlated with a lot of other important soil properties, like soil texture, soil organic matter content, or even soil salinity and soil water content. So in the context of the current study, we want to know what is the soil water content, what maybe is the salinity, how much organic matter is there to help us delineate those management zones that Dallas was just talking about.
So, electromagnetic induction is a type of sensor that generates a magnetic field in the soil, which induces a small current that then generates a secondary magnetic field. And the strength of the secondary magnetic field is read by the sensor, and it is used to estimate soil electrical conductivity. So, the benefit of these electromagnetic induction sensors is they're rapid, non invasive measurement tools to estimate soil electrical conductivity in the field.
And then finally, we have what's called NDVI, or the Normalized Difference Vegetation Index. And this is a measure of how much light is reflected off of a plant canopy. In this case, we're talking about turf grass on a golf course. And this reflected light is correlated with how much chlorophyll is in the plant or how green that plant is. And it also is related to plant density. And so, because of these two factors, you can use NDVI as an indicator to assess whether or not a turf grass is healthy or not healthy.
I am so thrilled about that. I'm getting re-excited. I'm getting really, genuinely really excited about this because I love research that is like, here's a bunch of things and let's do research to see like what the relationships between them are, because I'm always so fascinated between like, how do you know it's this factor and not that factor? Or how do you know, like if you have different turf grasses that are normally like a different shade of green, like how do you make sure that your NDVI sensor thing is not the technical term that I've just invented, is like reading the correct, it's not being like, oh, this is unhealthy, but it's just a different grass species or whatever. So I am very thrilled and fangirly right now. So to control my chill, we will continue a little bit here. So I think that's a great start. So basically what you're looking at in this research is kind of, if you can get these measurements in non-invasive ways, how can you correlate them to turf grass and or soil properties to make sure that you're then applying what the plants actually need, um, and not wasting things that you don't need. I just kidding, I lied. I'm going back for a bonus question. These management zones, like how big are they and or how many are you having in a fairway? I could throw out a number for how big those are of the fairway, but I'll be wrong. So I'll let you describe what that looks like.
Yeah, so the number of zones that are within an individual fairway kind of just depends on the individual fairway, both on its size and then that variability within it. So if you have a fairway that's relatively flat and open to the sun, everything gets the same amount of sunlight, probably the same water content because you're not having different changes in elevation. You probably have a lot fewer number of management zones, and maybe even the whole fairway can be managed the same. However, if you have a very long fairway that maybe curves a lot and there's covered by trees on the side, you can maybe have upwards of 4, 5, maybe even 6 or 7 if you're getting on some of those really big golf courses that are used for like the PGA Masters and stuff like that.
Sure. Additional sub question. How do things like a sand trap impact that? Is that like a factor that's going to like impact the ground around it, or is it just like ignore this little chunk? It's just a hole in the map.
Yeah, so when we did this study, we ignored the sand traps and just drove our machines around them. Because, yeah, I don't think they really impact management, how you would manage the turf grass around it.
Okay. I just didn't know if it was like, oh no, the sand is like getting into other things around it that we need to manage for. Okay, now I'm gonna control my my fangirlishness. So we've laid out what this research was looking to do. So why don't you tell me a little bit more about how you went about it?
So, this research was done in Southeast Texas on two 18-hole golf courses, which belong to the same country club. This country club was located right outside of Houston, Texas. So, the main difference between these two golf courses was that one was planted with a zoysia grass cultivar and the other was planted with a Bermuda grass cultivar. Other than that, management practices were pretty similar in these two courses of the same country club. So, to take our measurements, we chose two fairways from each course to measure all of our different soil and turfgrass properties for a total of 4 different fairways measured. All measurements were collected once in April of 2021. We used a grid pattern to determine the locations to collect soil samples and turfgrass samples, as well as measure organic matter depths. We then took soil samples back to the lab where they were used to measure clay content, soil organic carbon, and the turfgrass samples were used to determine root mass. So in the field, we also measured soil volumetric water content and penetration resistance every 2.5 meters throughout the fairway. And we also collected continuous NDVI measurements using two green seeker sensors that were attached to the back of the same machine that took the water content and penetration resistance measurements. We used a non-invasive electromagnetic induction sensor to collect continuous electrical conductivity measurements. And this was done by pulling the EMI sensor along the fairway surface, going up and down, back and forth a few different times. So, to determine the suitability of using electrical conductivity for creating management zones on golf course fairways, we did 2 different things. First, we calculated the correlation coefficients to understand the strength and direction of relationships between electrical conductivity and each measured property. We also developed maps to visualize the spatial variability of properties throughout the fairways and help us identify similar patterns that will be useful for creating management zones.
So I guess my first question is like, if you had two properties that were like highly correlated to your electrical conductivity measurement, are you just like they must go hand in hand, like they must go hand in hand so it doesn't matter, or is there like a conflict of like, well, how do we know, like I'm throwing this out as an example that is like incorrect because I don't want to skew anybody's understanding of what you're actually trying to say. But if it was like this is related to like nitrogen and this is related to phosphorus, would you just be like, oh, nitrogen and phosphorus like get along and have a correlated relationship also? Or would you be like, we're not sure if this is because of the nitrogen or the phosphorus? Is that a reasonable question?
Yeah, I think so. And in this case, so the EMI detector is an indirect measurement of all of these soil properties. And so we did sort of a broad spectrum type correlation between all of these different soil properties. And it's not necessarily the case that the EMI can only be correlated to one of these things. It's entirely possible that it's correlated to multiple factors all at the same time. So I think that gets back to your nitrogen versus phosphorus example. It's possible for something to be correlated to both of those properties at the same time, and there's not necessarily like a conflict or a problem there.
Sure. So how does that impact your understanding of like how to apply that to a management plan then? Like if it was like nitrogen and phosphorus, would you be like, "Oh, we need to just put on both," or is it we need to do more research, or now we need to take a specific measurement to actually figure out what it is? How does that work?
So after you collect the electrical conductivity measurements, you make those correlations with, say, nitrogen. If you find that they're positive related, if you have higher EC measurements, you're going to have higher nitrogen content in that soil. So it relates to management in that if you have zones with lower EC, they will benefit from supplemental fertilization. It's not going to tell you exactly how much, like the exact rate to apply, but golf course superintendents have a pretty good idea. They usually apply in the same kind of base rate. It's just you're only applying to certain areas of the golf course compared to others, and that's what that EC measurement is telling you.
Okay. Okay. That's the missing piece I was hunting for. Yeah, that makes a lot of sense. So it's not necessarily like a tool where you're gonna be like, this measurement means that I should apply this much. It's just this is needs a little help or this one is fine. Just don't add more, that kind of thing.
Right, exactly. And typically with these management zones, you group them into generic categories like high, medium, and low. Like one area has a high clay content, another has a low clay content, but it's still up to the manager to determine how to manage those zones based on their own knowledge. And for the example of like soil nitrate or phosphorus, you would still need to do a soil test in that case to know how much that area would need.
Awesome. Okay. That is super helpful. Also, shout out to the people on the golf courses doing that work. Your expertise is incredible. I'm always floored by the expertise that people have to be able to make these decisions. Obviously not my area of expertise. So that's great. So you were correlating these relationships to figure out how you might be able to use this non-invasive tool to kind of give these people a general nudge in the right direction or just help them kind of define these general broad zones for their future testing and treatment. So what did you find?
So overall, we found that the correlations varied. They're pretty variable in the strength, how strongly correlated they were to each other, but also the direction of that relationship, whether they were positively correlated or negatively correlated with each other. And so not only were they highly variable between the two different golf courses, but they were even variable within the same individual golf course. So the two fairways within one golf course sometimes had different relationships for the same measurements. So an example of this would be turfgrass root mass. So in the zoysia grass course, we found that turfgrass root mass was negatively correlated with EC, but in the Bermuda grass course, this same relationship was positively correlated. So if we were working in a zoysia grass course, if we had EC measurements that were very high, this actually means low root mass. Whereas in the Bermuda grass course, if we had EC measurements that were very high, this means high root mass. Or if you want to get into like differences within course, if we look at specifically the zoysia grass course, so when we measured NDVI, which was that turf grass color measurement, in one of the fairways of the zoysia grass course, NDVI was negatively correlated with EC, but in the other fairway of that same exact course, it was positively correlated. So this was kind of very interesting, and it's not a big deal. It's not the end of the world. It just kind of means that before you implement a precision turfgrass management program, The superintendent is going to want to go out and collect these different measurements to determine what the relationships are, what the directions of these relationships are, in order to effectively and appropriately read these maps, interpret these values. Despite the high variability between the golf courses, we were able to find that electrical conductivity was significantly and positively correlated with soil water content and NDVI in 3 out of 4 fairways that we measured. So this was really good because water and nutrients are the 2 biggest inputs on golf course fairways. So the positive relationships mean that areas with higher EC will also have higher water content and a higher NDVI. So the most important implication of this being that zones with high EC would require less irrigation or less fertilizer inputs compared to zones with low electrical conductivity, which could benefit with supplemental irrigation or fertilization to improve turf grass quality. Along with the correlation coefficients, we also saw strong visual similarities in the maps that we created for these properties. And so you could really see similar patterns of variability throughout the fairways that could easily translate into different management zones. So the most surprising result from this study was actually effect of the turfgrass species on the strength and direction of these relationships. So this was really interesting because electrical conductivity was more likely to be significantly correlated with soil properties and turfgrass characteristics on the Bermuda grass course compared to the zoysia grass course. So out of all of the relationships we tested on both fairways in the zoysia grass course, the only significant correlations were on one fairway, and they were between water content and NDVI. So we're not really sure the reason of this, but there's definitely some kind of turf grass effect that we are seeing. I mean, it would be really interesting to look more into this and see how this influences precision turf grass management.
Yeah, I mean, that sounds like you all had some awesome results there. Intriguing, kind of mixed bag in some cases and very clear in others, which is wonderful. There's always more to learn in these kinds of things. So, these sensors, is this something that like a turf grass manager at a golf course can just put on their machinery that they already have? Like, is that something that is easy for them to implement, or is that like you have to bring someone in, or like how does that work?
Yeah, so it's fairly easy to use the instrument. You can just attach it to the back of like a gator or even like a golf cart and just tow it around the fairway back and forth. The biggest issue that I had using an EMI sensor was that the EC measurements are affected by metal within the environment. It's not such a big deal in agriculture because when you're out in the middle of nowhere in a field, there's not much metal there. But when you're in an urban environment, there's drain pipes, drain caps, even just like the power lines can cause interference. Players coming too close to the instrument if you're trying to do this while there's still people playing golf. It can all be a little bit tricky, but the use of the instrument itself is quite simple.
I'll just add to that while the use of the instrument is fairly simple, the instruments themselves are not widely held by people who aren't researchers. And so getting access to the actual piece of equipment might be a challenge for some turf managers. But I think this also provides a really great opportunity for these turf managers to potentially collaborate with scientists because most universities will have access to one of these pieces of equipment. So there's potential there, I think, to sort of expand the impacts of what these types of sensors can be used for.
Awesome. I love that. Yeah, I was thinking of Dallas's passion for community university relations. Sounds like a great opportunity to kind of bring those together. Well, that's great. That was me jumping ahead a small amount, but it sounds like you have a lot of questions that you can continue to ask and keep teasing apart these results and questions that you still have. So, what are kind of first some of the large scale implications and takeaways from this research? But then, Where are you headed next with it? What's on the horizon?
Yeah, so I would say there are really three key takeaways that come from this research. By being more conscientious about our water and fertilizer applications and just knowing more about our sites, these golf course fairways, we can one reduce the costs of applying both water and fertilizer. Water is becoming a more and more limited resource, and over time, we'd like to conserve that more. And of course, managers are always interested in cutting costs wherever they can as well. The second implication is that using these management zones based on the EMI technology allows us to really target these inputs where they're going to be the most influential. And this will allow us to improve the overall quality and even just the aesthetics of these fairways by using this technology. And then finally, by reducing the amount of fertilizer and nutrients that are applied, there's a good possibility that we can reduce environmental contamination by nitrates and phosphorus that can sometimes be transported either to surface water bodies like streams and lakes and things like that, or even to groundwater where a lot of people get their drinking water.
So, moving forward, we would really like to see more studies where precision irrigation, fertilization, management plans are actually being carried out so that we can gain a better insight into both the economic and environmental impacts of a precision turfgrass management program. We also think that more research is needed to fully assess the impact of the turfgrass species on the effectiveness of precision turf management, because we definitely saw a major contrast between the Bermuda grass and the zoysia grass species in this study, which might affect how well you could use EC to define management zones. So, the next phase of this research is actually conducting a precision management plan. And so, some of our colleagues, Dr. Chase Straw, who is now actually at Penn State, and his PhD student, Madan Sabkota, have been working on the precision nitrogen fertilization research project, where they're using EMI sensors to create management zones to determine where to apply various rates of nitrogen fertilizer on golf course fairways.
Hi, everyone. I hope you're enjoying the show. Interested in learning more? Briana and Dallas's paper, Using Electromagnetic Induction to Inform Precision Turfgrass Management Strategies in Sand-Capped Golf Course Fairways, published in AgroSystems Geosciences and Environment, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. Awesome. Yeah, great takeaways, great questions to keep asking as we move forward on this. And anyone who wants to get hooked into that on the turfgrass management side, I'm sure you guys can reach out. Which brings us then to our last three questions. So the first one is, if listeners want to learn more about any of the things we've been talking about today, where can they go?
Yeah, that's a great question. So, of course, there is the article that the podcast is based on where they can go. That is fully open access and anybody can take a look at it and see. There are some pictures there of the equipment that we used if you want to get a better idea of what that looks like. And there are also those maps that Dallas was talking about where we showed the spatial variability of all of these soil properties. But really, since the listeners are going to be located in a lot of different places, if you're interested in precision turf management in your area, it's probably best to reach out to like a local extension agent who might be able to point you in the right direction for your area, because not all of these areas will be the same.
So then, if people want to take the next step and get involved, be they researchers or turfgrass managers or golfers or whoever else, what can they do?
So, you can actually engage in precision management in your very own yard. Understanding the variability in your lawn by taking the time to notice which spots might become waterlogged after it rains, or spots where the grass doesn't seem to be growing very well. Maybe it's more yellow or it's just really patchy, it's not growing at all. Having a better understanding of this can help you save money on the amount of water that you're applying and fertilizer, because you're not going to be putting it where it isn't needed. And it can also help you become a better environmental steward um, by applying water and nutrients when, where, and in the amount that they are needed. So, as you're doing lawn care this spring, consider these few things first. Before watering or applying fertilizer, check the weather forecast for the next chance of rain. If it's going to rain within the next couple of days, maybe hold off till it's done. You can get a soil test each spring so you know which areas of your lawn are most nutrient deficient and apply fertilizer only on those patches. And then another really important one that is pretty easy to do, not a lot of homeowners really think about it, is just stop watering once runoff occurs. Once you see water start flowing into the street onto your driveway, that means that your turf lawn, your that means your lawn has reached capacity for the amount of water that it can hold, and you can stop watering because at this point, you're just wasting water.
Awesome. That is great advice. So, final question for you is, what is one fact about both of you that people wouldn't know if all they had was your research?
Yeah, so for me, I think a lot of people, at least in my professional life, don't know that I really love music and that I originally entered college as a music major.
Wow. Wonderful. Do you play any instruments or vocal or?
So I do. In high school, I was in both concert band, where I played trombone, and I was in marching band, where I played baritone, which is like a small tuba. And recently, I have started playing guitar again, and I actually just played guitar at an event last night.
Oh, fun. Congratulations.
Thanks.
Dallas, what about you?
So I've been knitting for a long time, ever since high school. I learned to knit. And so I've currently undertaken the project of knitting my four nieces and nephews blankets that kind of all match so they can have kind of matching blankets with each other. Um,
Aw, that's super sweet. I love knitting. That's a very cool fact. I like that a lot. Well, this has been a wonderful conversation about some really cool research in a very cool setting. So, thank you so much for your time. Yeah, and thanks for all you do. Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.